Good day everyone. I am Isel Claire C. Amanda, a biological engineering student, and I am here to present my thesis entitled Silica-based ionogels for bacterial absorption. And my thesis advisor is Ma'am Nanette Santos.
Safe drinking water is required for all useful domestic purposes including drinking, food preparation, and personal hygiene. However, water can be potential carriers of pathogenic microorganisms, which can negatively impact public health as well as the quality of the environment. In the Philippines, 1 in 10 people still need access to improved water sources. According to Philippine Statistics Authority, there are 50,058 reported cases of waterborne diseases from 2010 to 2019, and acute bloody diarrhea caused about 85% of these waterborne diseases. Diarrhea is the 8th leading cause of disease in the National Capital Region and among the top 10 leading causes of morbidity countrywide. In the figure, a significant increase is observed in food and waterborne diseases, which included diarrhea, hepatitis, rotavirus, and typhoid fever, from the year 2022 to 2023 based on a data surveillance reported by the Philippines Department of Health Epidemiology Bureau. Eliminating impurities such as bacteria is the goal of wastewater treatment. But one of the challenges is the ability of the bacteria to mutate and develop resistance. Adsorption has proved to be one of the most efficient methods in water treatment because of its high efficiency, superior performance, and ease of operation. Most adsorbents target dyes or heavy metals. Hence, it is with great interest to find an alternative new adsorbent for the adsorption of pathogens. In this field, ionic liquid-based gels, also known as ionogels, have gained a lot of growing interest. The ionic liquid is confined within the matrix of a solid network, hybridizing its properties with those of another component, resulting in a gel with the desirable properties of both the IL and matrix. ILs can be specifically created to achieve properties suited for particular applicability by changing the different combinations of cations and anions. The tunable nature of ILs and their functionalities in combination with a porous matrix material using the sol-gel method could be an attractive candidate for offering innovative adsorbent material that can deal with the increasing challenge of wastewater treatment. This study aimed to prepare a silica-based ionogel and check its potential as a promising candidate for bacterial adsorbent, using the gram-negative bacterium E. coli as a model. The results from this study may advance the knowledge of using silica-based ionogel as an alternative adsorbent material, targeting pathogens in the conventional adsorption method for water treatment to provide safe drinking water for the community. Also attain some of the UN Sustainable Development Goals, such as ensuring healthy well-being and achieving clean water and sanitation for all. Furthermore, ecological wastewater treatment process using conventional technique like adsorption process involving ionogels with antibacterial property aims to be an option for future science and research. For the methodology, the silica precursor used was tetraethyl orthosilicate and the ionic liquid 1-hexyl 3-methyl-imidazolium chloride. The acid catalyst used was phosphoric acid, and 2 non-pathogenic strains of E. coli were used. The E. coli NCTC 12900 and ATCC 25922. The E. coli NCTC 12900 was packed in a quick-state device containing the lyophilized microorganism pellet, an ampule of hydrating fluid, and an inoculating swab, while the E. coli ATCC 25922 was placed in a vial and cultivated using LB agar. LB broth and LB agar were used as the culture media. This is the schematic diagram of the methodology. For the preparation, of ionogel, it followed the sol-gel process based on the procedure described in the literature. So, TEOS was mixed with water under magnetic stirring at room temperature. Then, phosphoric acid was added dropwise into it with stirring and was continued for another 15 minutes. So, the ionic liquid with 0.5% weight concentration was then added in the mixtures of the silica precursor, water, and the phosphoric acid. The solution was covered with parafilm after and allowed to gel overnight while sealed at the room temperature. The ionogel was further allowed to dry in a drying oven. So both strains of E. coli were cultured for bacterial adsorption test. The concentrations of bacterial solutions before and after the adsorption experiment were measured optically using a UV spectrophotometer using the calibration curve at a wavelength range of 400 to 600 nm. The medium containing only the LB broth without the presence of E. coli served as the blank. The bacterial solutions taken from test tubes was placed in another visible cuvette cell and put into the spectrophotometer for analysis. The steps were repeated after 15 minutes to check the growth of the bacteria. Then silica-based ionogel was poured into these bacterial solutions and was carried out in a shaker at room temperature for 2 hours. After this, the bacterial solutions were again measured optically using UV-Vis for the final bacterial concentrations using the same procedure. Growth curves were monitored by changes in the optical density at 600 nm at 15-minute intervals. So for the proper waste disposal, a bleach solution, Zonrox, was used to kill the E. coli strain contained in quick stick for 24 hours and was disposed of in the regular trash. The vial containing the E. coli strain, ATCC 25922, and the bacterial suspensions was autoclaved at 121 degrees Celsius for 1 hour and disposed of in a waste bottle. This is the physical form of the prepared silica-based ionogel using sol-gel approach. In the sol-gel process, the sol underwent hydrolysis and condensation reactions, which resulted in polycondensation and gel formation. As observed in Figure 1b, this gel shrinkage typically arose during the aging period, and the collapse of the network occurred during the drying procedure due to the capillary tension in pore walls between the gel particles. A previous study reported that the antibacterial mechanism of the ionic liquid was attributed to different stages, including adsorption, as the ionic liquid is attracted to the negative surface of bacteria through electrostatic attractions. Table 1 represents the recorded absorbance values using the prepared silica-based ionogels. Before adding the ionogel, the bacterial growth caused an increase in the absorbance of the bacterial sample. The absorbance of all the samples increased after a 15-minute interval, indicating bacterial growth for the initial concentration. However, a minimal drop occurred in sample 2 containing the E. coli NCTC 12900, but it is not statistically different, which may be due to various factors such as cell death or lack of nutrients. Later on, after the ionogel was immersed into the solutions and put into a shaker for 2 hours, a significant drop in absorbance occurred for all the samples. The absorbance of all the samples increased after being measured again after 15 minutes. Most bacteria have a negatively charged surface, hence the bacteria were supposed to be adsorbed by positively charged adsorbents through electrostatic interactions. The absorbance dropped continuously for all the samples as contact time increased. The absorbance values directly relate to the concentration of bacteria in the solutions, as reported. Figure 2 shows the relationship of E. coli absorbance with time after immersion of the prepared silica-based ionogel. After 2 hours of contact, E. coli showed strong absorption, indicating a significant decrease in its presence, with 58.92%, 53.76%, and 50.97% E. coli removal for the E. coli strain NCTC 12900, and 60.09%, 71.19%, and 80.21% for the E. coli strain ATCC 25922 of samples 1, 2, and 3 respectively. At contact times above 135 minutes for both strains of bacteria, the significant increase in absorbance indicated the desorption of E. coli. The fluctuating results of the absorbance values implied the adsorption-desorption of E. coli by the silica-based ionogel. Nevertheless, the absorbance continued to decrease as the contact time increased. So like most gram-negative organisms, E. coli has a negative charge, which means that the interaction of E. coli with the external surface of the ionogel occurred through active centers like silanol groups, resulting in favoring the electrostatic interaction with the surface of the E. coli. However, the interactions between the bacteria and the ionogel by characterization were not examined in the present study. Further research would be required to confirm the absorption mechanism. So to conclude, in this work, a silica-based ionogel was prepared through sol-gel process. Gel shrinkage was observed in the physical form of ionogels during the drying procedure, which is due to the low concentration of the ionic liquid. A significant drop in absorbance was observed for all the absorption test samples, indicating a decrease in E. coli concentrations, suggesting that there was a strong absorption of E. coli after contact with the silica-based ionogel, with the bacterial sample of E. coli strain ATCC 25922 showing the highest percentage removal of 80.21%. A significant increase in absorbance at a contact time of 135 minutes means that desorption of E. coli occurred. As the contact time increased, bacteria were adsorbed to more accessible sites, leading to a continuous decrease in absorbance. In conclusion, silica-based ionogel is a promising candidate for adsorbent material that can absorb biological pollutants like bacteria. However, the present study did not examine the interactions between the bacteria and the ionogel and its properties. Further research would thus be required for the adsorption mechanism. Further studies and characterization analysis, such as the surface area, porosity, morphology, are needed to confirm the adsorption mechanism and the interaction between the silica-based ionogel and the bacteria. It is recommended to determine the concentration of the bacteria to be able to calculate the adsorption capacity of the silica-based ionogel, as well as the percent adsorption. It is also important to further assess about the ecological toxicity of the imidazolone-based ionic liquids to ensure an environmentally friendly adsorbent material. So that's all. Thank you.